students, myself Vijay. Today we are going to discuss one of the important and interesting chapter in chemistry, thermodynamics. Before getting into the chapter, you should know the meaning of thermodynamics. Thermo means, the term indicate heat, and dynamics, this term indicate flow. So chapter which deals with heat flow is thermodynamics. So thermodynamics, the term thermo means heat and dynamics means flow. So this chapter is mainly dealing with heat flow. So thermodynamics is a branch of chemistry which deals with the energy change. Which energy? Heat energy. So chemistry, it's a branch of chemistry which deals with the energy change occurring in physical and chemical process, or accompanying in physical and chemical process. So in thermodynamics, we are dealing with energy change. Which energy? Heat energy. Heat energy change accompanying in physical and chemical process. For example, if I am placing a piece of ice here, with time, this ice will absorb heat energy. It will absorb heat energy and melts to water. Right? So it's a physical process. It's a physical process. In this physical process, heat is exchanged because this ice is absorbing heat. So it's a heat change. Right? Now, if you consider the formation of ammonia, N2 plus 3H2 giving 2NH3. When ammonia is formed from nitrogen and hydrogen, heat energy will be released. So here there is an exchange of heat. There is exchange of heat energy. So in thermodynamics, we are dealing with energy change. Which energy? Heat energy. Heat energy change accompanying in physical and chemical process. So thermodynamics is the branch of chemistry which deals with the energy change accompanying physical and chemical process. I think it's clear till here. Now, in thermodynamics, we have to study 4 important terms. So, in thermodynamics, we have to study 4 important terms. First among them is system. Now, what is system? System means part of the universe chosen for observational study. In this entire universe, if I am going to study about this bottle filled with water, then this is my system. The part of the universe, the part of the entire universe chosen for observational study. In this entire universe, if I am going to study about this bottle, then this is my system. At the same time, if I am going to study about this glass filled with coffee, then this is my system. So, in this entire system, in the entire universe, the part which is chosen for observational study is known as system. For example, in this entire universe, if I am going to study about this pen, then this is my system. In this entire universe, if I am going to study about this board, then this is my system. So, system means the part of the universe chosen for observation or study. Okay. For example, if I am considering a bottle, considering a bottle filled with water as my system, let this be my system. This is my system. In this entire universe, I am going to study about this system. Okay, this bottle, then this is my system. Now, second one, surrounding. Remaining part of the universe which can interact with the system. So, except system, the remaining part of the universe which can interact with the system, they are known as surrounding. So, surrounding means remaining part of the universe, universe except system, remaining part of the universe which can interact with the system are known as surrounding. Okay, so there are 4 important terms in thermodynamics. First among them is system. What is system? Part of the universe chosen for observational study, that is known as system. Now, what is surrounding? Remaining part of the universe other than system, remaining part of the universe which can interact with the system are known as surrounding. Now, third one is universe. Now, what is universe? Universe means universe. Third one is universe. Universe. Now what is universe? Universe means system plus surrounding. System plus surrounding is universe, because we know that if you consider a bottle, then this bottle is my system. Bottle is my system. Remaining part is known as surrounding. So system plus surrounding, universe. Okay. And last and final important term is boundary. Now what is boundary? Boundary is the region of separation. India-Pak boundary. That means it is the region of separation between India and Pakistan. So boundary is the region of separation. So in thermodynamics, boundary means it is the separation between system and surrounding. So region of separation between system and surrounding is known as boundary. So these are the four important terms in thermodynamics: system, surrounding, universe, boundary. Part of the universe chosen for observational study is known as system. The remaining part of the universe which can interact with the system, the remaining part of the universe, let this be system. The remaining part of the universe which can interact with the system are known as surrounding. So system plus surrounding, universe. Now what is boundary? It is the region of separation between system and surrounding. Now boundary can be real or imaginary. Boundary can be real or imaginary. It can be real. Boundary can be real or imaginary. Boundary can be real or imaginary. For example, if I am taking a bottle filled with water, here, if water is taken as system, if water present in this bottle, if water present in this bottle is taken as system, then here boundary is this bottle. Here bottle is the boundary. If I am considering water present in this bottle, if I am considering water present, if this water present in this bottle as my system, then here boundary is bottle. So bottle is real. At the same time, if I am considering this water and this bottle, this entire bottle and water as my system, if I am considering this water and this bottle as my system, then if both these, water and bottle, is considered as my system, then here boundary is imaginary. Here there is no definite boundary. If I am considering, please listen carefully. First case I am considering water, only water as my system. In the first case I am considering only water as my system. That means this bottle is my boundary. Bottle is the region of separation between water system and air surrounding. Okay. At the same time, if I am taking this bottle and water inside this bottle as my system, taking bottle and water inside this bottle as my system, so that here boundary is imaginary. There is no definite boundary. So based on the type of system we choose, boundary can be real or imaginary. Okay. So these are the four important terms in thermodynamics: system, surrounding, universe, boundary. I think it's clear. Moving on to next topic, classification of system. Moving on to next topic, classification of system. Moving on to next topic, classification of system. Now, based on exchange of energy and matter, so classification, next topic, classification of system. Systems are classified into two types. First one based on exchange of energy and matter. Second one based on chemical composition. So systems are classified. Thermodynamic system. Thermodynamic systems are classified into two types. First one based on exchange of energy and matter. Second one based on chemical composition. Now, based on energy and matter, systems are classified into three categories. A, open system. B. Closed system. Third one, isolated system. Isolated system. So based on exchange of energy and matter, systems are classified into three types: open system, closed system, isolated system. Now, what are open system? Open system means system which can exchange energy and matter. System which can exchange energy and matter with the surrounding. So system which can exchange energy and matter with the surrounding are known as open system. For example, consider a cup of hot coffee. Consider a cup of hot coffee. This coffee is very hot. With time, it will exchange energy with the surrounding. With time, it will exchange energy with the surrounding. It will exchange energy. Okay, with time it will exchange energy, so the temperature will drop. For example, initially if the temperature is 90 degrees Celsius, with the time temperature will drop to room temperature or 25 degrees Celsius. Room temperature, average room temperature is 25 degrees Celsius. So with the time, due to exchange of energy, temperature of the system will drop, right? So here energy is exchanged between system and surrounding. At the same time, due to evaporation, some amount of water molecule, some amount of particle will evaporate, okay, to this surrounding. That means the system is exchanging energy, so the temperature decreases. At the same time, some amount of matter is also exchanged with the surrounding. So system which can exchange energy and matter with the surroundings are known as open system. I think it's clear. Once more, consider a cup of hot coffee or tea. With the time, the tea will exchange energy with the surrounding, so that temperature will drop. That means system is exchanging energy. At the same time, due to evaporation, some amount of particle will evaporate to surrounding. That means the system is exchanging energy as well as matter to the surrounding. Those systems are known as open system. Okay. At the same time, closed system means system which can exchange only energy. Closed system will exchange only energy. It will not exchange matter. System which can exchange only energy. Exchange only energy, not matter. For example, consider a cup of hot coffee or tea. Now I'm closing this cup with a lid. I'm closing this cup of coffee cup with a lid. I'm closing this coffee cup with a lid. Now the system will exchange energy with the surrounding, right? After some time, temperature will drop, hotness decreases. But since the cup is closed, matter will not exchange. It will not exchange with the surrounding. Evaporation will not take place because the cup is closed. That means here energy is exchanged between surroundings, but no matter is not exchanged. Those systems are known as closed system. System which can exchange energy, not matter. So last and final system, isolated system. What does mean by isolated system? System which cannot exchange energy and matter. Both are not exchanged. Energy and matter are not exchanged with the surrounding. Those systems are known as isolated system. For example, thermoflask. If you place some hot water in thermoflask, it will not exchange energy or matter. It will remain that temperature for a long time. For example, if you are taking water in a flask, thermoflask, if temperature of the water is let the temperature be 98 degrees Celsius, for a long time the temperature remain as such, 98 degrees itself. Okay, here energy is not exchanged. Here matter is not exchanged with the surrounding. Those systems are known as isolated systems. So first category, classification of system. Systems can be classified into two types. First one, based on exchange of energy and matter. Based on exchange of energy and matter, systems are classified into three types. Open system, system which can exchange energy and matter with the surrounding. Closed system, system which can exchange energy, not matter. Isolated system, system which cannot exchange energy and matter with the surrounding, are known as isolated system. Example for isolated system, thermoflask. Now, moving on to next classification. Next classification based on chemical composition. Based on chemical composition. Based on chemical composition, systems are classified into two types, homogeneous and heterogeneous. Homogeneous and heterogeneous. Homogeneous systems and heterogeneous system. Homogeneous and heterogeneous. Now what does mean by homogeneous system? Homogeneous system means system consists of only one phase. System consists of only one phase. For example, if we are taking milk and water in a vessel, milk and water, milk and water. You know that milk and water will mix each other so that you can observe only one phase. These two will mix each other and you can observe only one phase. Right? You cannot observe two phases. Milk and water, it will not exist as a separate layer. They will not exist as a separate layer. They will mix together to form a single layer. Right? So, system consists of only one phase are known as homogeneous system. Now, at the same time, if you are mixing oil and water, now when you mix oil and water, you can observe two layers. Water layer, above that you can observe oil layer. So here you can observe two layers. So system consists of more than one phase. More than one phase. More than one phase. System consists of more than one phase are known as heterogeneous system. So second category is based on chemical composition. Based on chemical composition, systems are classified into two types, homogeneous systems and heterogeneous system. Homogeneous system means system consists of only one phase. You can observe only one layer or one phase. At the same time, heterogeneous system means you can observe more than one phase. It can be 2, 3, etc. Okay, for example, when you mix oil and water, they exist as two layers, water layer and oil layer. They will not mix each other. So you can observe two layers. Those systems which consist of more than one phase are known as heterogeneous system. I think it's clear till here. So thermodynamics is a branch of chemistry which deals with the energy accompanying chemical and physical process. Energy change accompanying in chemical and physical process. Now, important terms in thermodynamics: system surrounding, universe, boundary. Now, those systems are classified into two types, based on exchange of energy and matter. Second one, based on chemical composition. Based on exchange of energy and matter, the systems are classified into open, closed, isolated. Open means exchange energy and matter. Closed, exchange energy, not matter. Third one, it cannot exchange both energy and matter. Now second one, based on chemical combustion. Based on chemical combustion, systems can be classified into two types. Homogeneous system which consists of only one phase. Heterogeneous system consists of more than one phase. It can be 2, 3, etc, etc. Okay, I think it's clear till here. Moving on to next topic. So moving on to next topic, macroscopic properties. Now what are macroscopic properties? Properties associated with macroscopic system. Macroscopic system means bulk system. Macroscopic means bulk. Macroscopic means it means bulk. B-U-L-K. Bulk systems. So properties associated with macroscopic system. Now in thermodynamics, we always consider bulk system. Bulk system means, if you consider this system, this is a bulk system, means it consists of large number of water molecules. I'm not talking about a single molecule. In thermodynamics, we are not discussing or we are not talking about a single molecule. We are talking about a bulk of molecule. Bulk of molecule. In thermodynamics, we will not discuss about single molecule. We always consider bulk of molecule. For example, if you consider all the examples which we discussed earlier. For example, first one, bottle full of water, bottle filled with water. We are not considering a single water molecule. We are taking a bulk of water. It consists of large number of water molecule. A cup of coffee. We are not considering a molecule. We are considering large number of water. In coffee, there are large number of water molecules. There are large number of sugar molecule. There are large number of caffeine molecule. There are large number of milk molecule. We are considering bulk systems. Right. In thermodynamics, we always consider bulk system. We are not concerned about single atom or single molecule. I think it's clear. In thermodynamics, we are not concerned. We will not consider about a single. We will not talk about a single molecule. We always consider bulk of molecule in thermodynamics. So all our systems are bulk system. In thermodynamics, all our systems are bulk system. So macroscopic properties means properties associated with bulk systems. That means system which consists of large number of atoms, large number of molecules, large number of ions. Because in thermodynamics we always consider bulk system. Okay, so macroscopic properties means properties associated with bulk system. If we consider matter as a bulk, then properties arises. Properties observed in this bulk systems are known as macroscopic properties. Properties observed in this bulk systems. System which consists of large number of atom or molecule. Those properties are known as macroscopic properties. Now, example for macroscopic properties are temperature, pressure, volume, density, mass, heat capacity, specific heat capacity, molar heat capacity, refractive index, surface tension, viscosity, enthalpy, entropy, Gibbs free energy, internal energy, etc. So there are large number of examples for macroscopic system which we study in detail in this chapter. Okay, these properties we will study in detail in this chapter. Okay, so properties associated with macroscopic systems, that means bulk systems, are known as macroscopic properties. Properties associated with or observed in bulk systems are known as macroscopic property or bulk properties. They are temperature, pressure, volume, density, mass, heat capacity, specific heat capacity, molar heat capacity, refractive index, surface tension, viscosity, internal energy, enthalpy, entropy, etc., etc., etc. Okay, these are the macroscopic properties. I think it's clear. Moving on to next topic, that is macroscopic properties are again classified into two types: extensive property and intensive property. Macroscopic properties associated with bulk systems. Properties associated with bulk system. If we consider bulk system, means a system which consists of large number of atoms or large number of molecules. Those systems are known as bulk system, and properties observed in the case of bulk systems are known as macroscopic properties. Now, these macroscopic properties are again classified into two types: extensive property and intensive property. Now, what are extensive property? Properties which depends on amount of substance. Macroscopic properties which depends on amount of substance are known as extensive property. Macroscopic property which depends on amount of substance. Okay, macroscopic property which depends on amount of substance are known as extensive property. At the same type, properties which are independent of amount of substance. Macroscopic property which are independent of amount of substance are known as intensive property. Properties which are independent of amount of substance are known as intensive property. Now, for example, if you consider a cup filled with water, and consider a big vessel filled with water. Now I'm giving heat energy. I'm giving heat energy to both this cup and this big vessel. So I'm giving heat energy, okay, to this cup and this big vessel. Okay, with time you can observe boiling. You can observe boiling. That means this water in this cup will boil, as well as water in this big vessel will boil. With time, when we supply heat energy, water present in both the systems, cup as well as in a bottle, a big vessel, they will start boiling. But there is one difference. When you supply heat, okay, with small amount of heat, when you supply some little bit heat, this cup will start, the water present in this cup will start boiling, because the water present here in this cup is very less, so it need less amount of heat energy, right? For boiling this cup, water present in this cup needs little bit energy or little amount of heat energy, because amount is less. So it will start boiling faster than this one, because in this vessel there are large number of water molecule. So to boil this water, we have to supply more amount of energy, right? So here heat, let the heat be Q. Q depends on amount of substance. Here amount of substance is less, so heat energy is less. We are giving less amount of heat energy. But here amount of substance is more. That means to boil those water molecules, we have to supply more amount of energy. So heat depends on amount of substance, right? So heat energy is an example for extensive property, heat energy. Okay, heat energy is an example for extensive property. I think it's clear. Here amount of water is less, that means you have to supply little amount, small amount of heat energy, it will start boiling. At the same time, if you consider a big vessel filled with water, it need more amount of energy to boil, so that here heat depends on amount of substance. Properties which depends on amount of substance are known as extensive property. Okay, so example, heat energy. Now if you consider temperature, here what? Now if you consider temperature or boiling point. Now if you consider boiling point, for these two systems, this is glass filled with water and this is a big vessel filled with water. Now if you consider boiling point for these two systems, you can see that the water present in this system boils at 100 degree, and water present in this big vessel also boils at 100 degree. That means temperature, boiling point means temperature. Temperature is independent of amount of substance. Temperature does not depend on amount of substance. In both the system consists of water. Now in both the system, water boils at 100 degree. That means boiling point, temperature. Temperature does not depend on amount of substance. So property which are independent of amount of substance are known as intensive property. So example, temperature. Okay, now extensive property means property which depends on amount of substance are called extensive property, and property which are independent of amount of substance are called intensive property. Now examples for extensive properties are heat energy. Okay, there are so many other examples for extensive property. They are heat energy, mass, volume, heat energy, let the heat energy be Q, heat energy Q, mass, volume, and all forms of energy, like all other forms of energies like work energy, enthalpy, internal energy, entropy. So there are so many other examples for extensive property. So property which depends on amount of substance are called extensive property. Heat energy is an example for extensive property. There are so many other examples for extensive property. They are mass. Mass depends on amount of substance. Now if you consider this system, so maybe mass of this be 2 kg, but here we are considering a bulk, very big system, so obviously the mass will be greater than this one. Maybe mass of the system be 25 kg. Here amount of substance depends on, or mass depends on amount of substance. As amount of substance increases, mass increases. As amount of substance decreases, mass decreases. So mass mass depends on amount of substance. So mass is an example for extensive property. Now if you consider volume, volume is also an example for extensive property, because volume also depends on amount of substance. If you consider 2 liter and 25 liter water, if you are considering 2 liter vessel, 2 liter, this is 2 liter filled with water, and if you are considering 25 liter, let this be 25 liter. As volume increases, amount of substance increases. So volume depends on amount of substance. As amount of substance increases, volume increases, right? So volume depends on amount of substance. So volume is an example for extensive property. Now there are so many other examples. All other forms of energies, all forms of energies are extensive in nature, like work energy, enthalpy. Enthalpy is a form of energy which we will study later. Internal energy, it's a form of energy. Entropy, it's a form of energy. Gibbs free energy, entropy. All other forms of energy, like work energy, enthalpy, it's a form of energy. Entropy is a form of energy. Gibbs free energy, internal energy, INTERNAL, internal energy. Gibbs free energy, etc. All these topics will be discussed later. So, okay, so these are examples for extensive property. Now, property which are independent of amount of substance are known as intensive property. Example: temperature, pressure, surface tension, refractive index, RI, refractive index, short form RI, refractive index, etc. Here also there are so many examples. Density, DENSITY, density. Okay, there are so many examples for intensive, which we will study later. Okay, now here you should know one thing. You should remember one thing. Density is equal to mass by volume. What is density? Density means mass divided by volume. That is density. We know that mass is an extensive property. Mass is an extensive property. Volume is also an extensive property. Both mass and volumes are extensive in nature, but density is intensive. Why density is intensive? Mass by volume, that is extensive by extensive. These two extensive will cancel each other, so density will become intensive. Okay, you should remember this thing. One extensive divided by another extensive, you will get intensive. That's why density comes under intensive property. Okay, so these are the examples for extensive and intensive. What are extensive property? Property which depends on amount of substance are known as extensive property. And what are intensive property? Property which are independent of, they will not depend on, the property will not depend on amount of substance. So these are the example, and all examples will be discussed later in this chapter. Okay, I think it's clear. Now one more thing. If we divide an extensive by extensive, you will get intensive. Density means mass by volume, that is extensive by extensive, you will get intensive. So extensive by extensive always gives intensive. Okay, extensive by extensive always gives intensive. At the same time, extensive by extensive always gives intensive. Intensive by intensive always gives intensive. Extensive by extensive, intensive. Intensive by intensive, intensive. Now, extensive by intensive you will get extensive, or intensive by extensive you will get extensive. You have to remember this, this thing. Extensive divided by extensive always gives intensive property. Intensive by intensive always gives intensive property. Now, one extensive and one is intensive, that is intensive by extensive or intensive, extensive by intensive or intensive by extensive, they gives extensive property. So you should remember this thing. Okay, I think it's clear. Moving on to next topic, state of a system. Moving on to next topic, state of a system. If macroscopic properties such as temperature, pressure, volume and number of moles, temperature, pressure, volume and number of moles have definite value, then the system is said to be in a definite shape, definite state. Okay, if macroscopic properties such as temperature, pressure, volume and number of moles have definite value, then the system is said to be in a definite shape. For example, consider this macroscopic bulk system. Okay, now if I am calculating temperature, pressure, volume and number of moles of the system, that means I am expressing the condition or state of that system. For example, if I am placing a thermometer, the thermometer value shows the temperature of the system. Let the temperature be 27 degrees Celsius. By using a manometer, I can calculate or measure pressure inside the system. Let the pressure be 1 atmosphere. Now, let the volume be 100 ml and number of moles, number of water moles, number of moles of water, let it be 100 moles. Now, here I am calculating all these four macro, all these four, pressure, temperature, pressure, number of volume and number of moles of the system. So here I am calculating temperature, pressure, number of moles and volume of the system. That means I am expressing the state or condition of the system. Okay, so what is state of a system? State of a system means if macroscopic properties such as pressure, temperature, volume and number of moles have a definite value. That means if you are calculating temperature, pressure, volume and number of moles of a system, you are expressing the state of the system. Then the system is said to be in a definite state. Okay, so state means it is the way of expressing temperature. State of a system means it's a way of expressing or a way of calculating or measuring temperature, pressure, volume and number of moles. If you calculate these four values, you will get a definite, you will get a fixed value. If you got these fixed value, that means you are expressing the state or condition of the system. I think it's clear. Moving on to next topic, state function and path function. Moving on to next topic, state function and path function. Now what are state function? Properties which depends on initial and final state and independent of path are known as state function. Properties which depends on initial and final state and independent of path are known as state function. And what are path function? Properties which depends on path and independent of state. So there are two types of functions, state functions and path function. So state function mean properties which depends on initial and final state and independent of path. Whereas path functions are properties which depends on path and independent of states, that is initial and final states. I'll explain this with an example. Consider a person moving from first floor to 10th floor, okay, of an apartment. First floor to 10th floor of an apartment. Okay, consider a person moving from first floor to 10th floor of an apartment. Now, he is carrying 2 buckets of water. He is carrying 2 buckets of water. Now, he can move either by taking lift or he can take stairs. Right? He can move from first floor to 10th floor either by taking lift or by stairs. Now, when he moved from first floor to 10th floor by taking lift, he is doing some work. Let the work be W. He is doing some work. Let the work be W. When he moves from first floor to 10th floor by taking stairs, again he is doing some work. Let the work be W. Now, both the works are not same because when he take stairs, he have to do extra work, right? He had to carry those 2 buckets and he had to walk. So, he is doing extra work. That means, here the person is moving from first floor. Let this be initial state to he is moving to 10th floor. Let this be final state. Now, he can use 2 different paths. Either he can travel, he can move by taking a lift or by taking stairs. Now, work for both the paths are different. Work for both the paths are different. That means work is a path function because it does not depend on initial and final path. It changes with path. Work does not depend on initial and final state. It depends on path. When the path change, value of work also change. Path change. When this path, he is moving in lift, at that time let the work be W1. He is taking stairs. At that time let the work be W2. Both the works are not same because when he move by taking stairs, he had to do extra work. So, work is a function which changes with path. Work is a function which changes with path. So, functions or properties which depends on path. Work is a function which changes with path. That means it depends on path. So, functions which or properties which depends on path are called path function. They are independent of initial and final state. They will not depend. Work as a function which does not depends on initial and final state. It purely depends on path followed. With path, work changes. So, work is considered as a path function. So, example, work. Now, second example for path functions are heat. So, these are the 2 path function. In thermodynamics, there are only 2 path function. One is work and second is heat. Both of them depends on the path followed. They are independent of the initial and final state. I think it's clear. I'll explain once more. Consider a person. He is moving from first floor to 10th floor by carrying 2 buckets of water. Right? Now, he can move from first floor to 10th floor either by taking stairs or by taking lift. Now, in both the path, he had to do some work, right? But these 2 works are not same because when he takes stairs, he had to do extra work. That means W1 and W2 are not same. So, work is a function which changes with path. With path, work changes. So, work is a path function. Properties which depends on path and independent of state. Properties which changes with path and they will not depends on the initial and final state. In both the case, initial and final states are same. W1 and W2. Okay, in both the case, initial and final states are same. But with path, work value changes. So, work is a path function. Path function means functions which depends on path. That means they changes with path, but they will not change with state. They are known as path function. There are only 2 path function in thermodynamics, that is heat and work. Remaining all functions are state function. That means what are state function? They depends on properties which depends, that means functions which depends on initial and final state and independent of path. They won't depend on path, they purely depends on initial and final state. So functions which depends on initial and final state but independent of path, they are known as state function. Okay, except work and heat, all other functions are example for state function. Like examples like internal energy, which we study later. The later half of the chapter we will study this one. Internal energy, enthalpy, entropy, Gibbs free energy, etc., etc., etc. Pressure, volume, temperature, number of moles, etc. All these property depends on initial and final state, independent of path. But these two functions, they depends on path and independent of state. So these are state functions and path function. I think it's clear. Moving on to next topic, thermodynamic process. Thermodynamic process. Now in thermodynamics, there are 7 thermodynamic processes. There are 7 thermodynamic processes. In thermodynamics, there are 7 thermodynamic processes. They are isothermal process, isobaric process, isochoric process, adiabatic process, reversible process, irreversible process, and cyclic process. So in thermodynamics, there are 7 important processes. So I'll start with isothermal process. Isothermal. Iso indicate, what do you mean by iso? Iso means same. Iso means same or constant. Iso means same or constant. Thermal indicate temperature. So process which take place at constant temperature are known as isothermal process. So what are isothermal process? Process which take place at constant temperature. Iso indicate same or constant. Thermal indicate thermal indicate temperature. So what is isothermal process? Process which take place at constant temperature are known as isothermal process. So constant temperature means then change in temperature is equal to 0. Constant temperature. What is constant temperature? There is no change in temperature. Like constant temperature means there is no change in temperature. So in the case of isothermal process, delta T, that is change in temperature. Delta indicate change. T means temperature. Delta T is equal to 0. I think it's clear. Moving on to second process, isobaric process. What are isobaric process? Isobaric process. Iso indicate again same or constant. Iso indicate same or constant. And baric indicate unit of pressure is bar. So bar indicate pressure. So what is isobaric process? Process which take place at constant pressure. Process which take place at constant pressure are known as isobaric process. Delta P is equal to 0. Change in pressure. There is no change in constant pressure means there is no change in pressure. So change in pressure is equal to 0. So obviously, what is isochoric process? Iso CHORIC. CHORIC. So what is isochoric process? What is isochoric process? Process which take place at constant volume. Choric indicate volume. Iso indicate constant. So what is isochoric process? Process which take place at constant volume. So I think these 3 processes are clear. Okay. So delta V, change in volume is equal to 0. I think these 3 processes are clear. First one, isothermal process. Process which take place at constant temperature are known as isothermal process. Change in temperature is equal to 0. There is no change in temperature. That means delta T, change in temperature is equal to 0. Now what are isobaric process? Iso indicate constant, bar indicate pressure. So what is isobaric process? Process which take place at constant pressure. That is delta P, change in pressure is equal to 0. Now what are isochoric process? Process which take place at constant volume. Constant volume. Isochoric process which take place at constant volume. Okay. Change in volume is equal to 0. Moving on to next one, fourth one, adiabatic process. Adiabatic process means there is no exchange of heat between system and surrounding. If there is no exchange of heat between system and surrounding, then if there is no exchange of heat, if there is no exchange of heat between system and surrounding, those processes are known as adiabatic process. Process in which there is no exchange of heat between system and surrounding. Those processes are known as adiabatic process. In adiabatic process, Q will be equal to 0. Q will be equal to 0. Okay. So what are adiabatic process? Process in which there is no exchange of heat between system and surrounding. Exchange. No exchange. Okay. Now reversible process. Obviously you know that what a reversible process? Process which take place on either side. Okay. Reactant will convert to product and product will convert back to reactant. So process which take place on either side, they are known as reversible process. Now what are irreversible process? Irreversible process. What are irreversible process? Process which take place only in one direction. So one direction process. Process which take place only in one direction. Okay. So fifth process, reversible process. What are reversible process? Process which take place on either direction are known as reversible process. What are irreversible process? Process which take place only in one direction. One direction. This process will take place only in one direction. Reversible processes are usually represented by, okay, by taking two side arrow, by expressing. Reversible processes are usually expressed by writing two head arrow. One arrow again. Okay. Now irreversible process means one side arrow. I think it's clear. Now cyclic process. What are cyclic process? Cyclic process means a process. Let A be the reactant. A reactant A is undergoing a set of reactions. It is converting to B, converting to C, converting to D, and it is coming back to A. A reactant or a system, let the system be a system undergoing a set of reaction and returning back to its initial state. Those processes are known as cyclic process. Those processes are known as cyclic process. These are the 7 processes in thermodynamic process. These are the 7 thermodynamic processes. I think it's clear till here. Now we have to include 2 more points in reversible, irreversible and cyclic. Those points will be included later while discussing next topics. Okay, so I think it's clear till here. Okay, so I'm winding up today's class. So see you guys. Take care. Bye. Have a nice day. Thank you.